So I'm very much not a podium kind of guy, so I'll be walking around. So 4 parts to this talk, and there's a bit of an obvious pun here on where, yeah? So where are those robots, because it's a bit disappointing that we haven't got them. And where are the robots, because I need to know where they are in the world. So there's the bit of the pun. And let's start off with where are those missing robots, okay? Because what's our perception of robotics? And if you're like me, it's a bit disappointing, yeah? Because I was promised this, okay? And, and I should not have been promised this, right? Because this is science fiction. So, okay, science fiction, great, we all love it, okay? But this is actually quite damaging. This fella here is damaging in several ways, okay? Firstly, it doesn't exist. It is a country mile away from existing. So when we talk about robotics in the media, could we not print that? Because that's not what we're talking about. It's far closer to a Hoover, okay? There's a disparity between reality and science fiction. So the media certainly preempt it and we predict it as a society. We love this stuff. We're slightly scared. Why are we scared? Let's have a think about that. This actually is a real robot. This is a PR2 made by Willow Garage. It's about as good as you can get for a general purpose device. And I'll be talking a little bit about general purpose devices and how you could make a general purpose robot to see how hard it would be. One of the goals of this lecture is for me to pull apart that disappointment and turn it into excitement about really what's possible. And a really big thing we need machines to do is generalize. So you show them some training data, and then you say, the world's going to be similar, but not identical. And you should learn from what I'm showing you so you can cope with the unusual. So we should be teaching machines. Why? Because we can never, ever, ever hope to tell a machine about everything it needs to know. That's a stupid idea. It's clearly not true, right? And what's happening now is in this era of big data, where we're still trying to figure out what big data really means, other than just there's lots of recorded stuff, this stuff's going to start getting easier, because we'll see so many examples and have access to so many examples. How sure should a machine be before acting? This idea of introspection, about saying, well, I think this is my model of the world. I think that's a stop sign. I think that's a toddler, but it might not be. Okay? That's going to be really important when we start to act in the world and make decisions. The perception of perception. It's really hard to build a seeing machine. We're going to be working on it for a very long time. One of the things we don't actually know what seeing means. Imagine someone said, I'm going to build a machine that fixes a roof. Well, that's fantasy. Very, very hard. But here's actually what the machine is seeing. Let's say C, receives down a wire from the camera. If you were presented with that, can you figure out where the slates are? This seems hard suddenly, doesn't it? It seems quite hard. Understanding that that's slate from that? No, you need the rest of the fact that this is a roof. You need all this context, you need the rest of the image to do this. Suddenly this doesn't feel quite so easy. Okay, so again, this is from Andrew. What's happened here is we've plotted, this is pixels by pixels, it's just like the image. And we've made the height of this graph the color of the image. So if it's white, it's going to be really high. And if it's black, it's going to be low. Anyone see what it is? I thought we were really good at perception. Now you can. Wow. Yeah, Andrew's is the coolest slide. That's just great, isn't it? I think that really, really shows it. Okay, so it's the same data. Nothing changed. It's just it was put in context for you, for your visual centers back here that have evolved for a long time to be good at seeing images in the whole and that recognition. But that doesn't put us off. The not so easy problems are the most exciting problems. It's why you get so many people working on this kind of stuff, machine vision, machine learning, and robotics. It's the best area. Okay, so I hope I've pulled apart for you why we should not accept science fiction pictures of what's possible. We shouldn't think anytime soon we're going to have humanoids being general purpose machines, okay? I don't think we're going to have that. Came to see something about robots. Here is one. So we bought a Segway and stripped the parts down and then built something on the top of it. Now this is very much what the Mobile Robotics Group is about, in that it's not about the device. The device is really good to become an engineer with and learn about robotics. But the magic, again, lies in the text files that we produce. The software is where all the good stuff is. So what data comes from the device? Okay, so we've got some lasers here. I'll talk about those in a minute. A camera at the top, that's looking in, 5 cameras looking around, and one of those gold bar cameras at the front there. Okay, so if we know how we're moving because you've got the stereo camera and that's rigidly bound to the lasers, infrastructure free without any GPS or putting any beacons in the world or changing anything about the world, which we should never do because it's expensive and a bit dull, we can start to build some really quite nice 3D maps for low cost. Okay. And this is the robot just trundling around New College. You saw that video of it coming up with the trajectory, and here is sort of the 3D model that it produces. So what we did is put some lasers and some cameras on a thing that you can put in a rental car. And I rented a car and drove around London in the summer. And for free now, we're mapping with no GPS, just this rigid laser, no spinning laser, quite nice maps of London, okay, in quite detailed 3D. Why would being able to stick something like that on a car and drive through a city be useful to us? We are not condemned to a future of congestion, accidents, and time wasting. I think that modern robotics lies at the heart of a solution to fix some of these ails of modern society, and we should have a go. Let's ask some questions. Let's really step back from transport and say, look, are you sure it makes sense for me to have to be in control and driving all the time for the future of humanity? So let the cars drive, okay? Let the cars bid for insurance in real time. Let the cars drive some of the time. So to do that, you need some cars. We work with BAE, and they very nicely gave us the Bowler Wildcat, which is an autonomous car, which is a fantastic beast to get us started that we outfitted. Our other collaborators, Nissan, gave us 2 Leafs. So these are all electric cars. These really are the future of transport. We took those from the forecourt to autonomy in 4 months. Here you go. Here's the wonderful team that did this. So how does it navigate? Well, it's this jazz dance idea again. I've built that 3D model of the area that we're in, and we have, at the back of it, a laser. Okay? So I know what the 3D model, because I've driven through before, should look like. And that laser light is, ooh, fancy. That laser is painting the world. Here is the 3D structure of the world in the white, and here's the red. Now, as I move through the world, I can fill it, I can paint a part of the world. I build a swathe of my local scene. And if I'm in the right place, that local scene should look like the map that I built earlier. So interfaces are important, and here you go, we have an iPad to drive the thing, and again, it says, yeah, I can drive you if you want. You've just got to go through these steps for me because the car knows where it is. You've been driving it for a while. It says, yep, got a lock, I know where I am, and you're good to go. And you're off. There is a chicane here. It's not as crazy a start as you think. Can we take one of these cameras and have the thing drive it by itself? Answer is, yeah, we can. What you're seeing here is the car's memory. So this is the live image coming in, and this is what it recalls from earlier. So images are recalled from memory here, get matched with the live image here, and then recede off into a new experience. You've got to have some sense of what's going on in the world. So we could paint the markings of the road. This is the rules of the road. This is a roundabout. And the green and the red here are the obstacles that the thing's seeing. So if I had stood in the middle of the road, I would appear like a great big green and red square, and the car would stop. The model here is that we'll drive some of the people, some of the time, in some of the places. And cars will get better at doing this over time because cars know where they are. Knowing where you are is a fundamental problem of robotic science and has awesome application. Is society ready? No. No, we're absolutely not ready. Imagine we had a domain where you could save, you could save lives, 99 out of 100 lives you could save because you were using a robot. But one of those 100 lives was being killed by the machine. Would we accept it, or would we say, could we have the extra 99 killed, please? Okay, I'm not sure we're ready for machines to be saving lives and, at the same time, causing damage. Here's the big message. If you remember one thing from tonight, it's that you guys in the schools should be programming, okay? Computing and robotics, machine vision, machine learning is about writing the right text file, and here is one, okay? The great thing about programs is it's just a text file. Here's a piece of code that can drive a car. I just gave it away. Okay, it can't, by the way, that's just some videos. But that's the, that's the point, okay? So if you're not programming this weekend, why not? Programming computing is not about using the print dialog box, Okay, if we don't start teaching computing and software properly, we are walking into a brick wall in about 12 to 15 years' time. So we'll turn around and say, why is it we only use computers? Okay, why aren't we actually doing something with it? So please get with making the text file. So what happens now? And this is my last slide. Tomorrow afternoon, the robots will be better. Next week, the computers will be better. Day on day on day, these machines are getting better. We'll have better software. We'll have more data. We'll have more communications. We'll know more things. It's cumulative. It's the integral. We keep adding bits of knowledge. And we will turn around someday and say, Struth, look at that robot. There is no way that thing was designed. You're absolutely right. Because day on day, week on week, our computer programs and our products are being selected for fitness of purpose. Okay, they're being selected against being useful for us as humanity. And the good bits get reproduced and perturbed by the engineers. Of course the machines are coming. We're evolving them. Thank you very much.